Okay, so you might have to write your own differential equation. So let's say we say the rate of the number of bacteria, y, in a culture, so rate of change, so dy dt is directly proportional, remember that means k, to the number of bacteria, and remember number of bacteria is y. So you could have to write your own differential equation. So now let's do separation of variables. So we get dy divide by y and multiply our dt to the other side. And then we're going to take the integral of both sides. When we take the integral of both sides, we have the natural log absolute value of y is equal to kt plus c. And we're going to e both sides and get y. Remember that we're going to make big C e to the kt. And what you notice is for the first time ever, we have double constants. I have k a constant and I have c a constant. So what do we do if we have two constants? Well, guys, if you have two constants, we're going to need two initial conditions to be able to take care of these and solve for our constants. So we're going to start with the 0 and 2000. And remember, 0 is time and 2000 is our y, amount of bacteria. So I'm going to say 2000 is equal to big C e to the k times 0. And we get c e to the 0 is 2000. Therefore, c is 2000. Well, that wasn't so bad. So now we have our equation. Y is equal to 2000 e to the kt, and I need to solve for k. So I have another initial condition. This time we're going to use 3 and 10,000. Keep in mind this is t and this is y, and let's solve for k. So 10,000 is equal to 2,000 e to the 3t. And this is where we're going to get a funky k, so just go with me. So if I divide by 2,000, I get that 5 is equal to e to the 3t. And remember, we're solving. Oh, do you guys see what I did? So that k was 3, and this should actually be 3k, because we're solving for k, right? So we're going to take the natural log of both sides, and I get that 3k is equal to the natural log of 5. So k is the natural log of 5 times 1/3, okay? So where does this put us into our final equation? Our final equation is y equals 2,000 e to the 1/3 natural log of 5 times t. And I know it looks crazy, but we had two constants to solve for in this equation, all right? Now I can answer some questions about this. How many bacteria were present when t equals 5 hours? Well, I'm just going to plug in 5. So 2,000 e to the 1/3 natural log of 5 times 5. Make sure when you type this in your calculator, your 5 is outside of that log, okay? And we should get about 29,240 bacteria. And don't trust my word on that. Make sure you double check, okay? What I really like is a second follow-up question. The second follow-up question says, find the time t when there were 35,000 bacteria. And remember, that's y. So now we're going to set our equation equal to 35,000. And I know that you could put this in y1 and y2 and find the intersection, but we want to do it by hand just to make sure we know how to do this. So I'm going to start by dividing by 2,000, and I should get about 17.5. And in order to solve for t, we're going to have to log both sides. And I have the natural log of 17.5 is equal to 1/3 natural log of 5 times t. And we're going to multiply both sides by 3 to get rid of the 1/3. and then divide by the natural log of 5. Now guys, I'm aware you could do this in your calculator and get decimals along the way, but you want to hold out as many decimal places as possible to get the most accurate number here. So plug that in your calculator and press pause. And if you're coming back, you should be at about 5.335, and I think our unit was hours. Okay, so I'm going to take you through one more of these, and then I'm going to let you guys try one on your own. Okay, so again, you're writing your own differential equation, the rate of change of the number of bears n, so we're talking about dn dt, rate of change of bears, is directly proportional, so some constant, to 1200 minus n. So what we want to do is we're going to solve this separable differential equation, and we need to get stuff with n's, the 1200 minus n on this side, and we need to get our dt on this side, and we're going to take the integral of both sides. Now, don't forget that there is a u substitution going on here. So we've got 1200 minus n, and du would be negative dn. So since I don't have a negative, this is really negative 1 over u du is equal to the integral of k dt. Okay, so I have negative natural log absolute value 1200 minus n is equal to kt plus c. Remember that when we go to e both sides, I can't e both sides until I get rid of that negative. So I have natural log of 1200 minus n is equal to negative kt. And remember, we're just going to keep this plus c. It'll just be a different c. Okay? We're going to hit both sides with an e. And when we do so, we get 1200 minus n is equal to big C e to the negative kt. Okay? And I hope I don't need to explain again why this became big C. All right? So we've got two constants. We've got a constant c and we've got a constant k. So let's go to our problem and we'll see that they have, first off, at time 0, there were 300 bears. And so we're going to use that first. We're going to say 1200 minus 300 is equal to c e to the negative k times 0. Please excuse my dog snoring in the background. So we have 900 is equal to c e to the 0. So c is 900. Okay? So then we want to solve for our other constant of integration. So far we've got 1200 minus n is equal to 900 e to the negative kt. And they give us another initial condition of, at time 4, there's 600 bears. So 4 and 600 time a number of bears. So 1200 minus 600 is equal to 900 e to the negative k times 4. So we've got 600 is equal to 900 e to the negative 4 times k. If I divide 600 by 900, that reduces to 2/3 e to the negative 4k. We're going to log both sides. And I have the natural log of 2/3 is equal to negative 4k. So k is negative 1/4 natural log of 2/3. Okay? Now, here's one part where I think you're going to have to be super, super, super careful. Remember that your equation was 1200 minus n equals 900 e to the negative kt. And our goal is to solve this thing for n, okay? So if I do that, we got to plug in our k. I've got 1200 minus n is equal to 900 e to the negative, and then I've also got negative 1/4 natural log of 2/3 times t, and I ran out of room there, okay? But what's going to happen here is this double negative situation right there is going to switch that to a positive. You could easily mess that up, so don't mess that up. So I have 1200 minus n is equal to 900 e to the positive 1/4 natural log of 2/3 t. Solving for n, we get n is equal to 1200 minus 900 e, I about messed it up, to the 1/4 natural log of 2/3 times t. And I apologize for running out of room here, okay? So that was kind of a nasty example, but our follow-up questions are pretty easy. How many bears will there be in 7 years? Well, guys, just plug in 7. So if we plug in 7, press pause, type it in your calculator, press play when you're ready to come back. You should get about 757 bears. Okay. Good kind of question I was thinking about is, yes, I know you could get the decimal number of that, but if you are doing a decimal, it is not completely accurate unless you're using the log form. Okay, yeah, you could use decimals just for writing it out, but in your calculator, you need to keep all the decimal places. Okay. In the previous example, we did one kind of like this, find a time t when there are 900 bears. So now I'm going to set my function equal to 900 bears. This will be some fun math. So if I subtract 1200, I get negative 300 is equal to negative 900 e to the 1/4 natural log of 2/3 t. Divide, and I get 1/3 is equal to e to the 1/4 natural log of 2/3 times t. Remember, if I go too fast, you can always press pause on me. We're going to log both sides. In doing so, I get the natural log of 1/3 is equal to 1/4 natural log of 2/3 t. So that means that if I multiply by 4 and divide by the natural log of 2/3, I should get my t. If I plug that in my calculator, I get about 10.838. Always include your unit of years, okay? Now, out of all of these questions, probably the most AP question of all of them is this guy right here. Stars upon stars upon stars upon stars. Find the limit of n as t approaches infinity. Now, guys, this bear population is not going to keep growing forever and forever and forever. So what are they asking us for here? They want the limit as t approaches infinity of this function we just wrote, the 1200 minus 900 e to the 1/4 natural log of 2/3 t. Now, you need to be able to do this without a calculator. I think the trick here is you got to know, what is this number right there? Well, that number is actually, if you plug that in your calculator, it is negative 1.01, give or take a couple decimals. So you know what this means? This is the limit as t approaches infinity of 1200 minus 900. And since that's a negative number, I'm going to take that to the bottom and make it positive. So why do I care about that? I care about that because as I plug in infinity, e is going to get bigger and bigger and bigger and bigger and bigger. So this number here is basically infinity. 1200 minus 900 over an infinitely large number. And what that means is that this quantity is going to get smaller and smaller and smaller and approach 0. So what's left? Well, what's left is about 1,200 bears. And that means that the limit of this function is 1,200. Okay? So what I want you to do is I want you to stop the video. I want you to do example 3 all the way to the end on your own, all the way through, and see what happens.